Das geht ja einfach.
Good morning. Good morning. Magdalene? Good morning. Good morning and welcome to the first of our lectures as part of the AAC workshop, Art, Architecture and Nature. Today we have Sven Plieninger, who came to us from Stuttgart, where he is partner at Schlaich, Bergermann and Partner. Stuttgart, one of the breeding grounds of engineer ideas, stretching back to the early concepts of how to build a TV tower, how to do tensile structures. In this tradition, we feel that Schlaich, Bergermann and Partner and Sven Plieninger carries these ideas on and forward internationally. He's also the head of the Shanghai office of Schlaich, Bergermann and Partner, in which capacity he has, together with Nico and Magdalene, built some of the largest structures imaginable. He's been involved with AAC from the early hours on, and his lectures as part of Vertical Life, the skyscraper structures, but also mobile and temporary membrane structures are very well received. And his research into hybrid timber construction, which the office is now doing, will be very useful for our current workshop. So please welcome back to AAC, Sven Plieninger.
Dankeschön. Do you hear me? Oh, wonderful. Thank you for this nice and warm welcome. And thank you for the every one of our art says thank you for the invitation. It's always a pleasure to be here. And but this time it's not about a large structure, as Enno mentions, and not about the high structures. It's about really tiny things. And I was asked by Walter, do you find such projects in your practice? And I was kind of wondering a little bit the same, because Magdalene and Annika asked me, oh, tell us something about pavilions. And I said, okay, why not pavilions? Everyone does pavilions. So we do also pavilions. But at the next moment, I said, oh, there's a lot of room for pavilions, but most of them are tiny, and most of our projects which we're doing together are kind of large-scale structures. But I found some of these pavilion structures in our practice, but I also brought some from other offices, which I feel they are very interesting and giving a complete picture of what I wanted to give. So oops, it's the wrong direction. It's the wrong direction. So I would talk first about what came to my mind when we talk about pavilions. I give you a bit an idea what Schleich Bergermann is doing in his practice and what are the ideas we like to follow, because this gives also the insight why we do pavilions. Yeah? And then there's a larger part which you can shorten about pavilions, and many of them are done not only with architects, they are done with artists. And so this is a mix of art and pavilion architecture, and some examples from others. And this was the question. I looked up in the internet. This is what the average German says. It's a pavilion. It's a lightweight, tensile structure which you can fold away, yeah, and which you can carry. So it's one kind of pavilion, mainly used on beer festivals and other occasions, yeah, where to celebrate and sell things. But I think this is not an adequate answer to the pavilion question. So what can a pavilion be? I looked it up, it's clear. So it can be a small garden building, a summer house, a kiosk, a temporary structure. It can be built for any purpose, for leisure, for shelter. Often it's an annex to a building, sometimes it's on top of a building. It sometimes also resembles a classical temple, so it's a shape of a temple, but not necessarily. In many cases, it's very small or it's tiny compared to the surrounding, and sometimes it's also embedded in the landscape or is kind of part of a landscape, part of a pool area or whatever. So what I learned from this is nearly everything can be called a pavilion, and so it was not too heavy to find some pavilions in our work as well. So what are the functions of a pavilion? I was asking myself a little bit. So it's always the question, as we have seen at the very beginning, is it something very temporary? I use it only for one occasion, yeah, for a short period? Do I have to use it in summer, winter, or which climate we have? Do we have to have climate protection in such a pavilion or not? Might it be open or closed, or even it's no shelter at all? It's also only something you can walk on, yeah? And how does it deal with the landscape itself, which is natural surrounding? Does it interfere a lot? Is it sustainable? Is it built from sustainable materials? Normally when you can reuse something or often use something, it's sustainable in itself, but also is there something in material? Are they done in a very proper handcrafted way, in an industrial way, or are they done more freestyle? That was quite interesting to find out for me. And so also the erection, the installation, the detailing is quite nice, what normally engineers really like to talk about. And these are the things I had the feeling I should collect some ideas. But first, I had a look also to the internet. So when you want to get inspiration, I think you at AAC, which are now in the workshop, you need to look for inspiration. And in Germany, there's a big tradition on garden exhibitions. And these garden exhibitions normally display a lot of small and tiny buildings. So the garden exhibitions are a huge fundus to get ideas of pavilions. And there are many people who know the Serpentine movement. Each year there is a new and nice pavilion, and these are the high-level pavilions which you can find in architecture. Always well-known architectures are doing a pavilion each year. This is, I think, the top level where you can get inspiration, because I think there's no lack of money in these pavilions. But what I feel it's more interesting is also to look into research. There's Philipp Block with Block Research Group at ETH Zurich. He does a lot of research in materials, but he applies these materials not because it's research in smaller pavilions. So the expression of its research is always put to a pavilion. So he rethinks shells, he rethinks concrete slabs, he works with timber and carbon. So this is a kind of inspiration. But also in Stuttgart, there's Axel Menges and also Jan Knippers, which are working at the University of Stuttgart. And they are working with timber. They are also working with carbon fiber systems. You could say carbon fiber, wow, that's a nice material for tension. They mainly use it as compression member, which I not really like, but they're doing nice examples. And also the production and the fabrication of these elements is very nicely done, so that we can learn a lot. This is what you can find everywhere, where you can look at. And what I thought is, I talk about pavilions and art installation in landscapes. So I give you a short introduction in Schlaich Bergermann's work and why we do projects, and then give some examples and point on particular details which I found interesting with projects I show. So we are actually an office of 280 people, built up from many nations. We are located in several cities, like in Europe, we are in Berlin, Paris, Stuttgart, and in Madrid. We have an office in Shanghai. You heard about that from Enno, where we do mostly the large-scale projects. We have an office in New York and Los Angeles and one in Sao Paulo. I think I have to learn this present a little bit. I think what is important, as you all should learn from your studies, you learn in such a workshop, architecture, engineering, working together is very important. It's a collaborative way of working. Ideas can be developed from a single person, but my learning from many years of working as a structural engineer, when you combine disciplines and work together as a team, you get the best results out of your work. And this is something which we do in the office. We have a really collaborative way of working. We have a lot of workshops. We have teams which are built up, sometimes large, sometimes small. And we have a long relationship with von Gerkan Mark and Partner, which we are really happy about. These are the disciplines we are working in. So we're working pretty much in bridges. You heard about tower. There's a lot of facade work. There's special structure, artwork, buildings. Everything is a building, yeah. And we're working on solar energy and as well on movable structure, which Enno mentioned also before. So the kind of mother of development in our Office of the Lightweight Architecture is Olympic Stadium in Munich, the 10th by Günter Benisch, which was inspired there by Frei Otto, and Jörg Schlaich and Rudi Bergermann, who are the founders of the office, worked as the head or the lead engineers in that project. And I would say you could call this a pavilion in a garden as well, because it's a lightweight roof covering a landscape. So even if it's, and this is the reason why I said it must not be small, for me this is one of the examples of a huge pavilion embedded in a nice landscape. And this is something where I said, okay, there must be more of them. Yeah, there must be more of them. So on these kind of structures like stadia, we work worldwide. A lot of projects are together with von Gerkan Mark and Partner. I always take one example of one section. This is Suzhou, which I did with Nico and Magdalene. And also here you can see there are smaller buildings resting on a plinth. Also this can be called maybe a pavilion, but these are sports buildings. Yeah. The main interesting thing with us as engineers in this project was, normally we do tensile structures, and there's a very famous principle of the ring cable roof, which we apply to many stadiums worldwide. And then we had this nice undulated shape of the Suzhou roofs, and can we make structural use of that? And this ended up in a single layered roof, and this is a kind of expression, I think we used that during competition, this picture, where we explained the clients, okay, there's a transition from a double layer cable stress or cable system to a single layer cable system. And this was the challenge at that project, which we had to work on. And in each and every project, we would try to find a new challenge. That's what we like, how we like to work. We do a lot of roof structures, glass, membrane, whatever they call roof structures. So they're also spread out worldwide. One example is also Suzhou, because it's one of the biggest grid shell roofs in the world. It was done together with Benoit Architects. It's covering more than 35,000 square meters. It's resting on a building, or it's resting on 4 buildings, yeah, and it's one single roof wrapping everything together. But the main interesting thing is with these grid shells, which have a long tradition and a long history, which can be found also in Hamburg. Hamburg Museum these days, Hamburg Museum, where it derives from, is how to mesh such a roof, how to handle deformations, how to handle in China especially the vibrations or the dynamics which derive from the earthquake. And this picture on the right is the process I'm really interested in. And this was because architecture and engineering, they have processes, and there is an interface that's where the form, the surface, and the net topology is kind of connected. The architect talks about function, form, and geometry, and the engineer talks about geometry, structural analysis, and optimization. And somewhere they match. And when this circle, this 8 is working well, you get a nice project out of a process. And this was the very nice thing with the Suzhou roof. We do a lot of footbridges. Yeah, I have one example. That's a bridge for Trumpf in Stuttgart, small company. Or no, it's not a small company. It's a very famous company doing laser technology. And the idea comes from an orange net, which you stretch across an arch. Yeah, then you have a tensile structure. This one is stretched, and when you would kind of freeze that, to the word freeze, I will come later on again. When you would first, you can remove all these stabilizing things, and you have a compression structure. Now it's a tension structure. At the end, it's a compression structure. And also here you can see the white fibers of the net are following the line of the forces. And so you can ideally learn from such a simple model how a structure could work. And the fun was that Trumpf, as they do laser cutting, they were well received the idea that we cut this kind of shape of the lines of the forces, or what the material which is not needed in the structure, we cut away by laser cutting. And this was done in a huge workshop. And as you can see, so it's like the cable net you have seen before. The lines are stretching out where there's no material needed. We cut it away. And the other material parts where there's force and density needed, they are still in place. That was a fabrication. That's from structural idea to fabrication. This was the idea behind the bridge, or what we were interested in. We do a lot of big scale bridges, roads, railroads. I brought one example, which is the biggest one actually in Hamburg. We are really proud of to do it together with GMP and also with WTM, which are engineers from Hamburg. That's a crossing of the Elbe, U4. And the very special thing here is there are the historic bridges of Freihafen-Elbbrücke, which are very famous, which are very important to the city of Hamburg. And in front of them, we add a new arch system. And this new arch system is half the height of the old arches, because we apply new technologies and new materials. The hangars, which are here in the back at the Freihafen-Elbbrücke, you see everything from steel. They're nearly invisible in our new bridges because they're made from carbon, because carbon can take high tension forces. And this allows us to crisscross the cables and to build this not as an arch only, it's a truss as well, not only an arch. And this allows us to bring down the curvature. And so it's like, the explanation was, it's like an onion. You put a next layer of technology, a next layer of development in front of the old bridges. And I think this story was quite nice to explain to the jury, and the jury found it very, very interesting to have these bridges in Hamburg. There's infrastructure more than this. Also with Van Gerkan, Mark and Partner, that's the starting point of these bridges. It's Elbbrücken Haltestelle, so it's a stop of Elbbrücken S and U-Bahn. And the very remarkable thing is that within the old environment of the steel structure, we found an expression to have a new roof expressing the same kind of thinking, steel as the exposed material, showing how the structure will work. And the tricky thing with this was how to develop the geometry again. Yeah? So the geometry of these girders, which are going across the barrel, are kind of curved. And to resolve such problems, such geometrical problems, that's something what is our huge interest. Yeah? So that's from inside. Inside it's smooth because the steel structure, as we can see it from the Freihafen Elbbrücke, is outside. It's very well visible, but the inner skin is very slick because the glass layer is inside. We do a lot of long span structures, which we call halls. Many of them are fair and exhibition grounds. So this is something we did, I would say, worldwide at 20, 25, 30 locations together with the colleagues sitting here. And each of these projects could say, okay, it's boring, it's getting boring. No, it's not getting boring because there are always specialities. And here in this one in Qingdao, especially there is a facade which is completely hanging. It's almost 30 meter high. And it's built with materials which are really, compared to the height and the width of the structure, they are comparably slender. And this is achieved by having kind of a fish belly system. And this is something then you can implement in such a project and give them a very special looking. High rises, we do a few. Also together, an example with GMP. It's in Foshan. It's poly building, and the one very nice point and the pavilion in that building is the top. It's the lantern. There's a big window at the top, which is glazed by a cable net wall, and behind that cable net wall there is a membrane stretched, and this membrane is housing special functions. So it's resting on top of a building. It's also, for me, it's also pavilion, and resting a restaurant and special places. We're doing buildings or cultural buildings a lot. This is a very, very small example, yeah, of a museum in Stuttgart. There's a collector, Mr. Fröhlich, and he collects collects pictures, and he built a depot. That's just a depot. The concrete thing is the most important. What is resting on top, this little pavilion, is just a meeting room for his his company, who is located next to it. The idea was how, and this is what I also like when I work with architects, is sketching. Yeah, when I feel this is very important to sketch and express yourself in form of a sketch. Could also be today could also be a electronic or a different kind of drawing. But my expression is sketches, and when you have colleagues, and this was the fun thing, where you can sketch together and find out how you can resolve such curved structure, that's the fun I like, or that's the fun I'm kind of attracted by. And the shape is maybe curved, but you have to bring this into a solution which can be kind of solved by the industry. And these days, when you have curved structure, you mainly combine steel and timber, yeah, because the timber you can machine very properly to any shape you want, and this gives you freedom to develop forms. And the steel is in most cases needed. You will see this later on in some more detailed examples, because the timber has its weakness. And we are used to long spans, we are used to high forces, and we always think what we can solve with steel, we also can solve with timber, and that's not true. So we have to also do the construction or select the materials or react with our construction, with our spans, with our systems on the material we want to use. That's also an important message. And that is what is inside here. That's a collection or a part of, it's only one wall, they have several walls. So this was the nice thing to have such a nice concrete block and have wonderful pictures inside. I guess you know what all these pictures are. And then there are the large scale projects. This is Opera in Shanghai together with Snohetta, where we developed the entire geometry, which derives from a fan, yeah, which you would need to cool down a little bit here. And this is a big stair winding up with a cantilever of, let's say, 25 to 27 meters. And this is kind of winding up. And this is built from so-called UHPC, ultra high performance concrete. So you can do concrete in a very thin manner, yeah, but very strong, because you use high strength steel, you use high strength concrete, and this allows you to do slender structures also in a kind of traditional material like concrete. And this is what the workers put up for sun shade on the stairs, and I would call this a wonderful pavilion, but this is only a sunshade for the one doing some welding works, but for me this is a pavilion. We do a lot of art installations together with different artists. I have some with me, or with architects. Simple one, this was in Beijing. It's just a metal plate where you cut lines and then you punch a mast through, and this gives this so-called spiky canopy. With Jose Sousa from New York, we did some walkable structures, very simple, but from these things you can also learn how to treat color, how to treat minimal, very tiny details and so on. It's also very nice. Or we work as university. One of my partners, Mike Schleich, is professor at the University of Berlin. And there was a huge development, it's called the Great Repair, where we think of, I think this is one of the challenges in the next years, that buildings have to be retrofitted or upgraded or whatever. And this kind of symposium was about how we can make buildings which are already existing, again, functioning for more than the next 50 years. And we have the great pleasure to work also, or had the great pleasure, unfortunately, to work with Christo and Jean-Claude. The latest project we worked on was Arc de Triomphe. We did all the wrapping of the arc, so all the structural engineering, and you would really wonder how much structural engineering is in such a little package. Yeah, we could not drill any hole to the arc. We could not fix anything, so everything was bound around, was stretched, was kind of hung from the top, and finally this all the lines, which you see here, where the cables or the ropes are walking along, they are given by the artist, yeah, and have to be followed very precisely. So to solve this took us 1.5 years, yeah, in order not to harm the building which is under heritage. But it's a huge fun, and it's a huge pleasure to do such things. So you see, you can look to every field, you find a lot of buildings, yeah? And I try to give a bit detailed insight to more projects. I question myself, what is the importance in a pavilion design expression, or is it structural logic? Must it be heavy or must it be light? Thin or massive? Can it be concrete, clay, brick, whatever? And you will see at the end, when my conclusion is given, what I think about that. This one I like very much. It's Peter Zumthor. It's not our project, but I like it very much because it tells a story. And I think also when you do pavilions or art in landscape, you have to have a story behind that. And this is a kind of chapel. And he brought together tree trunks. He bound them together, put concrete around, and burned away the timber inside. And this is how it looks like from the inner. And there's a very special story. It's a huge mass of concrete for sure, yeah, and it's a huge amount of CO2. But the main important thing is the story behind it, yeah, and how people feel when they enter this pavilion. And we are more speaking about lightweight, yeah. We're coming out from the other side. We're coming not from the heavy concrete. We're coming from the lightweight structure. And Mike Schleich at the University in Berlin developed this infralight concrete, which is lighter than water, which swims in water, yeah. And we developed several buildings from this concrete. This concrete uses these clay bubbles which are inside to make it very light. And also this is a kindergarten in Berlin. It's also looking like could be a pavilion or could be used. This is cast in place. But what you also could do, because it's so light, you could do prefabricated elements. And this is a play when I would talk about a pavilion which should be heavy, then I would go for something which is prefabricated, which you can easily assemble on site, which you can move, yeah. And when you want to have a heavy material or heavy-looking material, it could be concrete, but it could be also a light concrete to help you to fulfill this task. This is a pavilion or proposal for IBA together with Barco Leibinger, made from these single elements. So you could it's like ein Kartenhaus, so it's just simple plates with a plate on top. That's a pavilion from concrete. There's clay as a material, and there's a very famous guy, Martin Rauch, in Vorarlberg, where I do my vacations next to, yeah, and it's called Lehm, Ton, Erde, Baukunst. So they're doing a lot of clay buildings. And these clay buildings, you would not expect that. That's a very famous small chapel in Berlin. It's the Kapelle der Versöhnung, and from the inside you see it's completely clay, that the roof is timber, yeah. So this material has a certain quality, which attracts people pretty much when you're sitting inside, having a service there. It's a very special emotion which is created because it's it's a natural material. And the idea behind from Martin Rauch is normally take the material from the site you're building and building up your buildings. This is his private house in Schlinz, yeah? And it's handcrafted. Everything is handcrafted, yeah? It's good. Someone wonder, ooh, that's tricky, always handcrafted. But now they erected a new fabrication, and they do prefabricated elements, which you can transport. And actually, many buildings in Germany are built up from these prefabricated clay elements. As a student, you can do internship at Martin Rauch's workshops, yeah, or a summer school. Also, something very nice, what you can do in Vorarlberg besides hiking and everything else. Clay is quite nice. There's a nice example from Querkraftarchitekten for the expo in Dubai. But as you can see, these are huge cones, and these cones are also from a clay structure, but they are also prefabricated. Yeah, they are also prefabricated, and that's the important thing behind, because these things within a short period, our reality in building industry is this: you don't have 4 years for doing a building. The periods of doing a construction get shorter and shorter and shorter. And so the solution could only be prefabricated repetitive elements. Repetitive is also very important in that context. And this they did for this pavilion. The engineers were Werkraumarchitekten from Austria. Clay, yeah. And there's a colleague of Philip Bloch at the ETH, and the next step could also be using robots or using robots and prefabricated clay cylinders to put together a form. And this is, so when you, for me it was also fun to look into that because I know about Grammatio Kohler, and they do these same shapes with clay, prefabricated clay elements which are laid like bricks by a robot. So in the ideas behind clay, it's always you have a building. This building can go, yeah. So it can disappear in the nature again, and that's the nice idea behind clay, which I think for a pavilion in a landscape could also be a solution. I say normally heavy, light, hard, and so on. We are more on the lighter side of the structures. Yeah? This is a very old example of Jörg Schleich. That's the pavilion for Buga 1977. It's a shell, yeah? Shell structure with a thickness of 1.5 millimeters. So 1.5 centimeters, that there's 1 centimeter written, it's a bit more, yeah, at the end. It's built from repetitive elements, yeah. These repetitive elements are built on one scaffolding, so you can do hundreds of them, what is very useful. They are built from fiber-reinforced concrete in 1977. That's what we're talking about these days a lot, and really not managing to do new buildings. This structure rests on little steel balls, so it's extremely light and extremely thought from the structural or from the flow of forces. So there's nothing which kind of interferes the flow of forces. So it's really natural form of force. So that's also the foundation are prefabricated. Yeah? This is this famous detail we learned from as students, used it a lot throughout all our work on bridges, on everywhere. Even for fair and exhibition halls, we use these ball joints. Yeah? And this you can also do with brickworks. That's, again, Bloch Research Group. It's also natural shape, built up from smaller elements. So it's also prefabricated, but what you need here, you see here the single, you have to bring them in the line of forces and have to fill the gaps. Yeah? And you need a formwork. Yeah? And this is the effort behind. Whereas you have seen in the shell in Stuttgart, there's one formwork, you bring these elements on site, build them together. Here you need a full formwork of the entire structure. And all these, also the Stuttgart shell of 77, are not, or they have predecessors. And one of the famous predecessors of all these shell structures is Felix Candela. And the Xochimilco shell from 58, yeah, this has a thickness of, let's say, 7 to 8 centimeters. It's cast in place. Was the kind of example for the Stuttgart shell, and even colleagues of younger age, like Santiago Calatrava, used that one for the Valencia. So it's also what I want to remind you, not only look back 5, 10 years, sometimes you have to look back 20, 50 years. There have been good ideas, and it's like the Wheel of Fortune. Everything is repeating. And when you properly look back, you find things which could kind of inspire you. And when you do them with new technologies and with new ideas, and refresh them with new ideas, I think this is also worth to mention. Oops. Oh, schon wieder die falsche. Gut. Felix Candela, we like really much as structural engineers. He did very simple buildings. That's a lightweight roof. But the clever thing is, he did foundation also as a shell. Yeah, this is the same shell like you see on top. Normally we use 2 by 2 by 1 meter concrete blocks. He only used a 10 centimeter shell as a foundation, doing the same work as a traditional, not well thought about foundation of these days. And this is the reason why looking back could be helpful and to learn. Heinz Isler is another one doing these lightweight structures. So this is it's a stop at a autobahn motorway. For me, it's one of the nicest pavilions you can find in shell structures. And I liked it from the very beginning when I did my studies in structural engineering. He did many industrial buildings, also with repetitive shells. That's Heinz Isler. And what impressed me a lot is the idea of form finding, because he's from Switzerland. Sometimes it's really cold in Swiss. So he just hung some fabric, sprayed it with water, and then he flipped it around. That's the same with the bridge I showed you before. Yeah? From tension into compression. And that's a play structural engineers like to talk about. And I think when I first heard about it was, I think, December lecture by Schlaich. Yeah? And I went home and tried to do something same at my home. And we like it very much. So we also developed for children a little play. Yeah? How to do a tent or how to do a kind of igloo. And that's the same principle. Frozen fabric on top of a shell, what you can hear, and then you can dig it out and you sit inside. But there are many other people inspired by this. There's, for example, it's also not very new. That's Gustav Düsing, which is, I would say he's one of the very famous young architects in Germany, actually. But what he does with his frozen tent is binding it back somehow for me, it's binding back to Isler. And Gustav was working with us together on Iguswerke. Iguswerke, a very famous building for all architects of a certain age. They have courtyards where they do their breaks. And this should be developed as gardens. Yeah? And he likes this lightweight architecture, the fabric one. And so we developed together with him a kind of ring system, which could be cladded by a fabric. And there, from this ring, different kind of curtains are hanging. And this then so it's more an outdoor space, an outdoor pavilion with a natural cooling and natural ventilation. Yeah? And this should be the look. So the curtains are freely hung from the roof, and with some magnets you could fix them to ground, so you can create walls. And this is a bit the thinking of lightweight pavilion been made from fabric. Yeah? They are not load bearing. The other one, which are frozen, are load bearing, but fabric can be used in different ways. I have a few examples which are, let's say, dealing with steel, aluminum, and timber. It's a question, do they always have to be three-dimensional? Yeah? Or are they linear? Are they perfect? Are they imperfect? Are they prefab or are they made on site? And this is it's a huge pavilion. It's for Volkswagen. So it's just a ring. Yeah, it's a Pringle, which you know from Lorenzen, I guess. And this ring it's using the curvature of Suzhou as well. So it's playing with the curvature. So the ring it's like this. It's wavy. It's fixed on 2 points on ground. Then you have a kind of structural cable net, which has curvature in 2 directions, giving the stability. And you have a membrane on top, and that's all. So simple, placing a Pringle on ground. You need a little bit of foundation, yeah. But this is kind of a simple element. When you would think it's smaller, you could bring it prefabricated and set it on ground, laid against each other. So also useful. That's also a pavilion called a bigger one from Porsche in Wolfsburg, Autostadt. A very, very advanced technology. It's a shipbuilding system. So you have inside structure, which is kind of giving the shape, and then you have a cladding, like you have the skin of a ship, which is made from curved stainless steel. So this is the very perfect version of a steel structure. So when you look to steel, they kind of need more efforts in workshops. They need more efforts in machining. It's the disadvantage or the advantage of steel. You can create more perfect systems. So all these elements are bent in the workshop, and then they're put together to house that cars. Very simple pavilion we did for Basel World. Basel World is a fair and exhibition ground, normally displaying watches, handbags, very luxury things. So they are not too happy when there would be a kind of a non-perfect structure, so they ask for a very perfect structure. So it's following something we are, as you as architects in GMP and we as structural engineers are always working about a folded plate principle, yeah, which is quite nice. So giving three-dimensional shape to simple blocks. And these you can dissolve in triangles. And these triangles you can elaborate in a kind of set of elements. And this set of elements, which then are repetitive, you assemble, and you can dismantle again and reassemble as a pavilion. And the most important thing to think about when you talk about such a system, which is which you want to assemble and dismantle again, is how the details are made. Yeah, so there's a very early thinking needed how to handle the detail. What material you work with here? It's aluminum because it's light. People can carry that. So everything has to be in a very machine in a very precise way, Swiss way machining. And finally, all the detailings which you have seen at the sketch have to be developed from the sketch into the drawings, into the machining, and this is the final result. So this working, how you hang things together, how you bind things, this is the tricky thing when you work on these pavilions, which work with linear elements. That is how it looks like. The roof cladding is a fabric again, which can easily follow that folding. Same principle, much more simple. It's Markus Heinsdorf. It's an artist, and we did together with him mobile spaces. These were pavilions. They were used to display German industry in India, yeah, at several locations: Mumbai, Bangalore, Chennai, New Delhi, Pune. There were a lot of places where to display. So all these pavilions have to be mounted and dismounted several times, and they have to be light. And so we decided this is how it looked like, and so we have different pavilions which are developed from very simple tubular sections, and these tubular sections have standardized lengths. They have standardized node points. When the spans get wider, there were sometimes cable suspensions, and also the outer skin was kind of folded, triangularly folded, because the triangle is always giving the stability to a structure. It's not parallel, it's triangle, what gives the stability. And then they were clad by different fabric materials to give the variety of shape, of looking. So there were round, edgy, combined ones, and they were built up from more or less the same elements, like a set of members. Yeah? And this set of members you could reassemble in infinite opportunities in order to create different kind of locations. And also, what is important in when you assemble things, several times, that parts are easy to erect, that they are not too heavy, and you can have workers from the point or from the city you're doing the erection. So they must not be very much trained. So untrained workers can do this assembly work with this system. And this is just a picture how Markus Heinsdorf, handled the variation. It's just some fabric stripes in some colors, which ends up with some light in some, I would say, beautiful India-like picture. Yeah? Because this colorful image, people liked a lot in India. This is Markus Heinsdorf, and he also did the Expo Pavillon Deutsches Haus in Shanghai. And at the end, it's the same principle behind that, but different material. He normally uses a lot of bamboo, yeah, and here he used bamboo as well. That's the picture of Deutsches Haus, yeah, and as you can see, it's quite the same. Single elements, node point, repetitive detailing, which you can bolt together very easily. Then there's a facade which is it's independent from the structure, which was laying in the back, and an independent roof structure, which is resting on the structure. So this was the build-up. There was an inner platform also from timber, an outer structure, and that's the main point. And everywhere you can see the triangles, yeah, for the stabilization. And there's an inner framework, which is kind of wrapped by the glass or by the fabric. That's from the side. Quite easy build-up structure. Very simple, but also the detailing is very tricky. Yeah, bamboo, you know, it's a tube. It's not each and every bamboo kind of grain. It's the same. Yeah, so you have to look at each of them. You have to machine them. You have to adjust the lengths. Everything you insert, it's hard to fix. So there were slots cut, things put in, and there was kind of rings wrapped around to stretch them. And all the detailing has to be done in a proper steel work. So that's a bit the tricky thing, how to connect, because timber needs always the steel, yeah, for the connections. And here it was done by kind of inserting a steel part and then wrapping and stressing these ribbons at the outside. So all the details they can all be kind of adjusted on site, because none of the systems has the same length, yeah, because they're natural. And so it's quite a nice pavilion, but with a lot of efforts, yeah. And one thing I want to mention is bamboo is a really wonderful material, yeah, and I think because it's structurally really nicely built up as a tube, and it has also these node points with the diaphragm, which stabilizing a tube so that the outer tube can be very thin, but it's still a natural material. But it has a really high strength. It's 4 times of our timber we have here, of the boreal timbers, and it's really growing very, very fast. So that's also an advantage in making use of it. So, but also the treatment of the timber, when you don't want to see these knuckles and all these things, it's a lot of craftsmanship what is needed. And what we have to say as well, there's a certain area where bamboo is growing, and it absolutely makes no sense to transport bamboo around the world, for example, to Germany. As well, it makes no sense to transport what is done actually timber from Canada or from Europe to China. And also, message should be use materials which are from the location, or which are kind of growing there, or which are kind of traditional there. For example, the bamboo, when you want to do solid beams from bamboo, what they also do, you have to split all these bamboo elements in small slats and glue them together, or you use even a bamboo fiber, because otherwise you don't achieve these kind of shapes we are used to. And Markus Heinsdorf, he used the bamboo as it is. But a construction industry would like to use it this way, and this is a lot of effort. And I think this effort makes sense in countries where bamboo is growing. This is the area where we have the boreal forests, where the timber is coming from, we are using. And so everything what is in the northern hemisphere, I would say, should mainly not use the bamboo for construction elements. This is a pavilion in Heilbronn, a smaller one with Sauerbruch-Hatten, full timber structure following these principles, only plates. So the idea was having a very simple pavilion, but there was some problems on site. There's a kind of a plaza. They wanted to orientate it so it was bent. Then there was nice lookouts there's a river in the back. Yeah? They want to have nice lookouts, so they cut away some of the elements. And there were additional trees, yeah, and so they shaped the form according to the existing trees. But as I said before, timber is quite easy to handle. You can adjust timber to any form. So this is the shape, and since these pavilions often are temporary, you have to think about the foundations, yeah, or how they are resting on ground. And here there's a simple system of steel elements which are put on really, really small piles. The steel can be taken away. Also, the piles could be taken away. But this is the least interference you can achieve with the ground. And this is also something you should think about when you embed a building in the nature, how you handle the ground you build on. Here, it's a very simple way. The elements are also very simple. Vertical members, horizontal beams cantilevering out back and forth, and a very thick timber blade on top. That's it. So timber is quite easy to use. It's a useful material when we talk about smaller buildings, smaller span, so the span should be very small. That's also fulfilling the needs we have these days of installation, so it's a climatized area. There's a lot of technique embedded in the structure, and this is more close to what we are used to as a construction as in other cases. So the bamboo is very different. The timber is kind of something we are used to. We have a beam in steel, we have a beam in concrete, and we have a beam in timber. But this is steel, this is concrete, and this is timber. So that's the thing to learn. Or this is the span of steel, this is the span of concrete, and this is the span of timber when you want to have the same sizes. And this is something scale, what you always have to think about. It's from the inside. I brought you an example on reuse. These are things we see each day, the cans, beer can or whatever, Coca-Cola can. And our colleagues in the New York office did a very nice project. It's called City of Dreams, together with Hofstra University and with Grimshaw Architects. And they had the idea to build pavilions in the park in New York. And these pavilions, then afterwards, the elements which are used for the pavilions can be reused, for example, as benches in a park. And they are done from the debris of the city, the timber, because New York is full of timber buildings. You would not expect how much timber is built in New York, and the cans used in the city. You would build a shuttering, yeah, and this would be filled with the debris, clay or whatever, dirt, and this dirt has to be muddy. At that moment you fill it in, and when it dries it gets cracks. And these cracks, you melt the aluminum, and in these cracks you kind of pour the liquid aluminum, and this creates the elements for the pavilion. This was the story. This is how the aluminum came to the melting site. Yeah, So they are pressed and they have to be melted, what is quite tough. Structural aluminum has 10 times the strength of, what they found out, 10 times the strength of aluminum can. Yeah, so it was tricky to get a structural behavior out of that material. It was really tricky to bring the mud into shape and to make it crack in a way that it is regular and that is controllable, but they managed to, and then they poured the aluminum in, and this is how these results look like. Yeah? It's a beautiful picture, but when you look close, you have a lot of areas where you have cracks, where you have things where you have dirt embedded and so on. So it's not a regular structural. It's not a regular structural material. It's a nice idea. It worked out, yeah. So, but instead of having this as the structural elements, we had to decide to build frames and attach this as a kind of a facade, yeah. So, should show not each and every idea can develop in a first go to a perfect result, yeah. But it's worth to try out such ideas in order to explore new possibilities and also to have kind of contribute to this discussion with a practical solution of sustainability. This is how it looks like when it's assembled. I could not imagine also using that as a bench, yeah, because when you have meshes which are that wide, you could not place your back on it, yeah. But it's a very impressive way of working, and because it's done by the engineers, by the students, and by the architects together, really on site, there's a lot of learning behind. And also doing this on your own and building up a pavilion on your own, this is also something you learn a lot. This is how it looks like. The more perfect version of that was done a few years before in Marzahn, Berlin, Christlicher Garten, by Relais Landschaftsarchitekten. So this was a kind of it's like you have a cloister in a monastery, yeah, you walk around, and the main point was that there was texts embedded in this cloister, and this was also cast aluminum. So, and this was Old and New Testament and also Psalms, and text is from that written on it. Yeah? So it's a place of contemplation. So the size is quite small. Yeah? The size is quite small. It's 3 meter by 4 meter is this cloister. So this is structurally easy to handle when you have a proper material, which you handle proper, yeah? And not using it from cans, which you have to remelt. It's developed like a puzzle system, yeah. So you have this kind of different system, and these different systems build up the entire geometrically the entire cloister. But the text that is for sure running across each and from one to the other element, and that's the tricky thing with it. So each element has to be drawn and developed, yeah. This is how the text is added to it. So, and as you can imagine, none of these are structurally the same, because none of the characters is the same, yeah, in a row. So the structural force, a flow of forces, is just a riddle, yeah. And this is how, but the process of how it is done is quite nice. So they just build up the positive forms from prefabricated elements, and then they put it in the sand form. They casted it. So this kind of process was the main idea. And what came out then was machined, polished. Yeah. So very different from the example I showed you before. And this only allows for aluminum. Yeah. Mm-hmm. So brought to site and assembled element-wise, and I think it's a beautiful example of a non-regular structure, very simple one. It's only 15 millimeters, 30 millimeters high, yeah, or thick. it's structurally working, but the story and the meaning behind it's very important. And I think it's a place to go where it pays out to go there and look at it. This one is what I mentioned before, Christo. He works on these barrel things he worked on this since '58, and also these kind of master bars or these stacks of barrels were always in their mind of Jean-Claude and Christo. And the huge idea, the big idea they had was the master bar somewhere in the desert, in Saudi, wherever, yeah, with a size which is huge. So the length of this is 320 meters, the height is 160, and we had the pleasure to do the structural engineering for that. It's not built at all. It's not built. The structural solutions are there, but and as you can see, it's a huge building. So 240 by 320 by 160, it's huge, yeah. And because of Christo and Jean-Claude financed all their projects themselves, they need to make the money for that first. And so they did a lot of smaller versions of that, sold a lot of pictures, sold a lot of exhibitions. And also here for a smaller one, that's the one in Hyde Park for Serpentine. He did one of that. We had the pleasure to do the structural engineering. So it's swimming on the Serpentine Lake. It's a small version of the huge master bar, should more or less look the same. These elements you know also from the other artworks of Christo. These are these plastic cubes which float, yeah. On these floats we erected a kind of very, very simple scaffolding. And to the scaffolding, this was a drawing by Christo. This is how it looks like. So it's only 40 by 20 meters. And on this scaffolding, which you can buy everywhere, yeah, plus some steel elements to get a proper surface, which is not wobbly on the lake, and some layers of these plastic cubes below. The entire structural system was done. And so there was the question how to really simple to the fixation of the barrels. And when you look from behind, it's also you also can go with very simple solutions to express yourself, to build your building. So it's a timber blade connected to the barrel. There's a few bolts, and that's it. And that's a reinforcement mat. So quite easy. That's how it looked like at the end. And hopefully the ones who now are in charge of the work of Christo and Jean-Claude managed to build a big master or get the founding for the big master. This would be a pleasure to do this in the future. I did not talk about glass. Many of our projects are about glass, and so I want to conclude with glass. Glass, you can have materials, as we all know, from the windows, but you can have glass molded, you can have glass poured or glass casts, yeah, or machined glass. There's many variations of glass you can have, and I have two examples brought with me. This one is the pavilion for the victims of the attack of 11th of March of 2004 in Madrid, where this is a glass cylinder with an inside membrane, and the glass cylinders is in the inside membrane. There's some writing on, which is kind of giving the condolences to all the people who were harmed, and the outside elements or the outside walls built up from glass bricks, and these glass bricks are specially developed. They're of this size, like 300, 200 by 70, have this special shape in order to form a irregular surface, yeah, and get a smooth outer skin. And they were also, this is melted glass, filled in a form, then they have to be pressed. So the energy consumption of such a you can imagine, of such a glass element is high. And then they are heated to treat them, yeah, because they should not get cracks when they get cold. And at the end, they have to be cooled. And finally, they are just built up like a brick wall. And the glue in between was hardened by UV light. Like you know, maybe from the dentist, they sometimes use a UV light, and this hardens the plastic which is filled in your teeth. And that's more or less the same what they used here. Yeah. So that's from the inside where you can look up. And this picture, what I showed with the text on it, was when you look up here. That's how it looks like. You see a little bit the inner bubble of the membrane, and that's the outer glass skin. And a final project which we like very much is from Pay White. It's Kvalala. It was built in Venice, yeah, by a foundation which basically deals with glass. And all who know Venice know that there's a big glassmaker tradition, yeah. And Pay White is playing with this. Kvalala was the idea of there's a river I think it was in her hometown, but it's in the US, and this river has meanders through the landscape, and during different daytimes, during different seasons, there's different light, and she wants to reflect that in her artwork. This is how it looks like. It's built in a garden, yeah, on opposite island of the Venice center. It should be a walkable structure, just a wall where you can walk along. There are doors in between. The surrounding is also very natural, and the color was very important. Yeah? The structural engineering is quite simple because you have heavy glass blocks. You can erect a wall. Since it's curved, it's no problem with structural engineering. Yeah? It's always stable. The blocks are 300 and somewhat long, 120 by 120. There were a lot of investigations on how to achieve the color. And then she talked to the people working on Murano, and one of these companies did all the castings. And this is how the casting was done. So they melted the glass, then someone poured in a magic powder of color. Yeah? One was steering around like a witch, yeah? And then they were pouring the blocks, and this was the result of the block. So blocks were cooled down. Some of them had to be cut, and this was the variety of glass blocks they did. Pay White, P-A-R, White. So then we had to do a planning how to build that up. Well, how is the foundation again? Because it's really, really heavy. Yeah? You have to bring it on ground. So there are clear glass blocks, and they have not this shape. They still have this gaps. It's a temporary work. This is how they brought them up. It's nothing else than doing brickwork. This is when you look along. There are some doors in. Very colorful. When you cut these glasses by machine, this is the pattern you see inside. And so when you have light together with this artwork, this is the nice thing at this point. It's not about structure. It's about color. It's glass. It's fun. Yeah. So this is also nice for a structural engineer, even though there's no big structure in it. So what to take away? For my feeling, there's no limits in size of pavilion. Yeah? You can use any material you can imagine. You should a little bit think about, is it sustainable? Is it from the location? How to handle it? Yeah? Structural concepts, you can either give them a real structural concept like you see from the shells, yeah? Or from Zumthor, you see there's no need for a structural concept. Both is possible. I like the other way around. You have to be really clear about the efforts, yeah? What you have to spend in order to erect such a thing. That's something you always have to have in mind. What are the efforts to do this pavilion I'm designing? And you should a little bit think about the sustainability. And I think the very important thing behind the pavilion, and maybe also your task you have, find an idea and find the matching expression to that idea. The story is the most important, because when I look to all these artists' works, the story is what is behind. I like this idea of the river, which has different colors, and these different colors are in the glass, even though glass is quite a energy-intensive material, but this is an idea which is brought to life by some material, and this is the real important thing. Find an idea for this, what you are designing, join forces with engineers and artists and whatever, and develop a proper solution. And this is the way normally we like to work. We work all the time with the colleagues here, and I hope you will find good solutions for your tasks in AAC this year. Thank you.
Sven, this was not a lecture, this was a firework. And you just concentrated on so-called pavilions. You could have started with towers, with bridges, with movable structures. And what you did is what is ingenious. That means ingenium, creativity. In our world, only the advertiser thinks to be creative. This was a wonderful story now. Thank you.
Thank you very much. I like to add, thank you, yeah, but I'm not a lecturer. I'm a practical engineer. I love working together with colleagues and love to sketch down solutions and find solutions for problems or challenges, and normally we would say challenges. And there's no much philosophy behind. It's just taken from our work. And I find within the combination with others, this is the story. You cannot build a story on your own. The story is always built together with others, which contribute to your work. And so we are contributing to an artist's work, to an architect's work, and only when this process is well done, then we have nice results. It's not a standalone solution, what we develop normally.
Thank you very much, and thank you very much for being here so early in the process of the workshop, so we can do exactly what you just said. You mentioned the Opera House, and you mentioned also Gustav Düsing, so there is a chance for me to point you towards our YouTube channel, where we have Snow Hatter's explanation of the Opera House, and Gustav Düsing will be here with us on Thursday night to give his insights. We continue with structure tutorials this afternoon in the AAC studio, so please again thank Sven Plieninger very much for making this lecture for us especially.